Alright, now we finally arrived at the final part C. And silly Mapoi had realized that she left up a couple of pages of part C on the previous video without even answering it because I forgot to delete those slides. Anyhow, part C could be a make it or break it kind of section because here it's actually not as bad as it seems. Even though what I'm going to tell you right now, you're going to see sets of questions that all belong under the same topic. And here in this set, like all the other sets, you're going to see this question. Sometimes your answer from one question is needed for the other question. So you need this to answer that. And sometimes you're going to need this to answer that and this to answer that. And there are a lot of sets that are like that. That means whatever you get here is going to affect what you get all the way here. So what does this mean? What if I get something wrong here and then does this screw up everything? Not necessarily. You could still screw something up here, you'll lose the point. But if you follow along with what you're supposed to do for the remaining questions, you could still get those points with the incorrect numbers as long as you know and you're supposed to do the correct process, because that shows the graders you still know the physics. You just screwed up something over here, but you know what to do everywhere else. So you can still get points even though you may have screwed up something earlier on. So for my advice, you have to follow along the entire way. That means you must go in order, 66, 67, 68, 69. But if you're going to see, this one is kind of special. You don't have to, because this is something that's on the simpler side. All right, now let's start with 66 to 69. And this is kind of like on the easier side, not going to lie. So you're going to use a ruler to determine the scale using the vector diagram. So if you see here, I brought out our protractor. Chances are they're not going to give you a ruler, but you will have these protractors nevertheless. If you notice, on the bottom are inches, right up here are centimeters. Okay, now let's bring this up over here. I hope this thing is correct. Anyway. Oh, I could just totally alter this however I want. This is totally inappropriate. Anyhow, that's not a real protractor, so I can't use this one, honestly. Okay, so I just had to double check on the answer key to see what it was. So here, I've adjusted the size of my protractor so that here you'll see what the answer is supposed to be. So we're measuring this right here. 5 centimeters long for this 2 kilometer vector. So you'll see in your answer booklet, if you happen to have it, for number 66. So 1 kilometer, oops, scratch that, let me delete that part. So it's not going to be 1 kilometer, it's going to be 1 centimeter is equal to how many kilometers? So here we have 2 kilometers is equal to 5 centimeters. And so we're going to do our proportion. 2 over 5 equals x over 1. Okay, 2 divided by 5. You'll get that x is equal to 0.4 kilometers. So our answer here is 0.4 kilometers is our scale. So for every centimeter here, it's about 0.4 kilometers. Okay. Now on the diagram in the answer booklet, what you have to do is use a ruler to construct a vector to represent the hiker's resultant displacement. So all you need to do, resultant displacement, meaning we're starting from our starting point and go to where he ends. All the way up here, the resultant, like that. It's almost the same as the hypotenuse. That's all you need to draw for 1 point. For number 68, what is the magnitude of the hiker's resultant displacement? You can measure the length of it and use a scale to get it, or you can use Pythagorean theorem. That's what I'm going to use. And you don't have to show work even to get this point. So 2 squared equals plus 1.4 squared equals c squared. C is going to equal, you should get approximately 2.4 kilometers. You are allowed to be within a range. You don't have to get these exact answers. Same with 66. They do have a scale or a range in which you're allowed to be within. So you may not get the exact answer, but as long as you're close enough, they will give you the point. All right, so that's our answer for 68, just 2.4 kilometers. 69, now you're going to use this protractor to determine the angle. So let's line it up here. See this right here? You're going to line it up. Oops. And it should be about 35 degrees. That's our answer. That's it. Simple. Now we've arrived at this part, 70 to 74. So these are examples in which answers do carry over. So we'll start with 70 to 71. Calculate the spring constant of the spring. So again, you need to use an equation from the reference table. So we're solving for K, spring constant. We have a force of 12 newtons. Force used on the spring is 12 newtons. And the spring and the toy is compressed this much. That's our X value. So there's only one equation that fits all these variables. Show this work, and you'll get the answer. Should get approximately 170 newtons per meter. To get that unit is important, and that's the point for 71. All right, numbers 72 to 73. Calculate the total amount of elastic potential energy. So this is potential energy in the spring. This is where we need to carry over our answer. So this is what I'm going to talk about in a bit. And our x is still 0.07 meters. So our equation here is PES is equal to 1/2 kx squared. So this is an example of what I'm talking about. What if you get this wrong? And you bring it over here, and you plug it in, do all the work, and you get an answer. And it still doesn't follow what the answer key says. You can still get the 2 points here, so long as you bring your answer over here and plug it in accordingly with the proper work, and the answer that you get according to your work. So here, this is where the grader has to follow exactly what you do, and they have to give you the points for that, because you're showing that you know what you're supposed to do, you know the physics. It's just that you kind of screwed up here with some numbers, I guess. So let's move on. We're solving for this. Don't forget x is squared. You should get 0.42 joules. That's our answer. All right, now 74, identify one form of energy to which the elastic potential energy of the spring is converted when the figure is pushed up by the spring. So, what happens when you compress this sucker down and then you release it? You'll see that the toy is going to move. So, what is the energy of motion? Kinetic energy. That's one form. And is it going to go in a certain direction? It's going to go upward to a certain height. So, that's also potential energy. And you'll also hear a sound, etc. So these are all valid answers that you could write. All right, 75 to 80. So here we have a 12-volt battery with this much current connected in parallel, and the lamp is operating at this much power. So 75 asks us to actually draw a diagram of the circuit. So we have to draw this circuit and know how it's supposed to be connected. So here for 75, we're going to start with our 12-volt battery. Flow through a circuit that contains a lamp and a resistor connected in parallel. So that means we have to draw branches. So that's our branch for the resistor, and here is our branch for the lamp. So drawing like this will get you the point. Keep in mind, you don't have to label the parts for the point. Just keep it as is. That's all you need to draw is just the circuit symbols in the appropriate orientation. All right, that's 1 point for 75. 76, calculate the current through the lamp. Okay, so here we have voltage. Voltage is equal to 12 volts. We have current as 0.6 amps, and our power is 6 watts. We need the current through the lamp. Okay, keep in mind that this 0.6 amps is before it splits up. because now it's going to split up into two smaller currents right here, because this is a parallel. Current splits up here. What we do know, this is the power of the lamp. This is also the voltage running through, because while 12 volts here is in the battery in a parallel circuit, it's still 12 volts going through. So we could still use something like this. P is equal to I times V. 6 watts is equal to I times 12 volts. 6 divided by 12, I is equal to 0.5 amps. All right. That's what's going through this branch. That's our answer. 78, determine the current in the resistor. That means now we're going to figure out the current through this branch. So we got 0.6 amps equals total before the split. 0.5 amps equals the lamp. So that means, what is our current going through? It has to be 0.1 amps for the resistor. That's our current going through the resistor. All right, 79 through 80, calculate the resistance of the resistor. So we should also keep in mind that voltage stays the same. So that's still what we're going to use. V equals 12 volts. We're looking for R. And now we found out that our current through that resistor is 0.1 amps. V equals IR, 12 volts equals 0.1 amps times R, 12 divided by 0.1. R is equal to 120 ohms. That's our answer. And here, now we're on to this section, modern physics section. Determine the energy in electron volts of an emitted photon when electron transition from n equals 3 to n equals 2 occurs. Okay, so I'm going to overlay that table over there, over the set of questions we already completed. So we're looking for n equals 3 to n equals 2 for hydrogen. So we look for this hydrogen's diagram. We look for n equals 3, negative 1.51 electron volts, and n equals 2 is negative 3.4. We need the energy of the transition energy. Okay, the amount of energy in electron volts of the transition. So we don't have to show an equation, but anyway, initial minus final. Initially it's at 3, so it's a negative 1.51 minus a negative 3.4, and you should get 1.89 electron volts. That's our answer. That's all you need to do. 82. Determine the energy of this emitted photon in joules. So we're turning electron volts to joules. If you remember my weird word, measured. So we're going from electron volts to joules, so we multiply. We multiply by what number? So taking a look right here, 1 electron volt equals 1.6 times 10 to the negative 19 joules. So that's the number we're going to multiply by. 1.6 times 10 to the negative 19 joules. Multiply those together and you get approximately 3.024 times 10 to the negative 19 joules. And that's our answer. That's all you need to do. All right, 83 to 84. What is the frequency of the emitted photon? So now we got our energy in joules. So again, you have to carry these answers over. We're looking for frequency. So what's the equation that relates these? Well, it's going to use this value as well, h. So E is equal to h times f. So 3.024 times 10 to the negative 19 joules is equal to h, which is, on the reference table as well, 6.63 e to the negative 34 joules, that's seconds, times our frequency f. Divide, and you get our frequency to be We're going to get about 4.5 times 10 to the 14th hertz. That's our answer. And then we have to identify the color light associated with this photon as our final question, which means we're going to need something from the reference table. Okay, let's pull it up in a bit. So I'm going to pull up this section from the reference table. And see, these values for each color is only given for frequencies. So if we have 4.5, that means we have to look at this. Let's tilt this over. We're in this range, which falls under red. So the color of our light right here is red. That's all you need to state. Now, again, this is an example where you have to go in order, so you carry the answers over. If you get this wrong, you're going to get this different, and you're definitely going to get this differently. And what if you end up with a different frequency that matches to a different color? So long as you match the color to your calculated frequency, then you could still get the point because you did what you're supposed to do. Again, I reiterate, 2-point questions, use an equation from the reference table. 1-point question, you don't have to show work nor use an equation from the reference table. And then, again, answers carry over in part C, go in order, but you can still get points even if you mess something up as long as you do what you're supposed to do. All right, now I highly suggest you guys do some more practice. I hope this was helpful to some of you guys, and best of luck again. Yeah. Pass or fail, all I want is for you guys to just try your best on this test. See you around.